Here we'll cover absolute value graphs also. Absolute value graphs, you can see, have a V shape to them, fairly similar to a parabola except for that you have a sharp edge rather than a rounded part. The reason why you get the V shape is because inside of these bars that I'm boxing in, all of the negative values get changed to positive. You may recall that ordinarily the graph of y equals x would look something like this. You would have a straight line passing diagonally through the origin. It starts negative and becomes positive. When we apply the absolute value bars, instead the negative values are inverted and become positive, symbolized by this orange line I'm drawing now. Then all the positive values stay positive, and so you end up with a V shape because the left side is reflected onto the positive part of the y-axis, but the right side stays the same. Again, it's similar to a parabola, although slightly different, because whereas a parabola's values can end up positive because of the square, these values in the absolute value function end up positive because of the absolute value bars. Also similar to a parabola, we have a left arrow and a right arrow on the graph. As with our previous graphs, a left arrow represents negative infinity and a right arrow represents positive infinity when we are talking about our domain. Therefore, based on the fact that we have those arrows, we can say the domain for this first function is negative infinity to infinity. Also similar to a parabola, we do have a minimum in this graph. And that minimum occurs where I've placed this red dot at y equals 0. We can also see that we have two up arrows. Anytime that you have an up arrow in your graph, even one at all, gives you a range that ends in positive infinity. We can say now our lowest y is 0, and our highest y is positive infinity. Therefore, our range will go from 0 to infinity. Recall also that 0 will get a square bracket because 0 is included in the range, but infinity is not included in the range because infinity is not a number. Therefore, we'll say 0 to infinity. To find f at 2, we locate 2 on the x-axis, draw a connecting line up to reach the graph, and now read the y value, and we can see that y value is 2. So we'll say f at 2 is 2. Now we look to the graph on our right side of the page, saying y equals absolute value of x minus 1 on the outside of the absolute value. We can see in this graph that we do have some negative values. The reason for that is the negative 1 that's on the outside. If you have a negative on the outside of the bars, you can still get negative values on your graph. However, let's begin with the domain. Notice that we do have a left arrow and a right arrow on this graph, and we can say automatically that the domain is negative infinity to infinity. This will be the case for any absolute value graph you see in this course. For our range, let's look for a minimum or a maximum. We can see that we have this point at the bottom that I'm going to circle in red. This will be our minimum, and we'll try to read the y value. Notice that this y value is not marked, so let's try to estimate it. We can see that the distance from 0 to 2 on this graph is symbolized by this red arrow I'm drawing. We can also look below the axis and see that that's about half as far as 0 to 2. So if the distance above the axis from 0 to 2 is this far, then half of that distance would be 1. However, since we're going below the axis, we actually say negative 1. So we'll say our minimum is y equals negative 1. Negative because it's below the axis, and 1 because that's about half of the distance to 2. Notice we also have up arrows on our graph. Up arrows represent positive infinity when we're talking about range. So we'll say our range starts at -1 and goes to infinity. -1 will have a square bracket, infinity will have parentheses because -1 is included, infinity is not. Now, if we look for f at 2, we'll circle that in orange. And notice we are directly on the axis. And anytime we're directly on the axis, our answer is automatically 0. So this is how we examine the domain and range for absolute value graphs. You may also notice that our range of -1 was written right here in the function. That -1 that was on the outside tells us where our minimum or maximum is.